This week, the maiden voyage of Application Security Weekly, episode 0, will follow. We'll be talking about the rise of application security, a brief history of application security, basically why we decided to do this show, which is awesome. Very excited. Our second segment, we're going to cover some news in application security, including, I think the primary news this week is Meltdown and Spectre, some of those CPU bugs in Intel, and some that may even touch AMD architecture, but Keith will have all the details on that for our listeners. In Learning and Tools, Keith got me excited about this SANS Secure DevOps Toolchain poster, which I also want multiple copies for my office and all of our developers as well. So stay tuned. This is the first episode 0 of Application Security Weekly. This is a Security Weekly production. This episode is brought to you by IT Pro TV, binge-worthy learning for IT teams. Why is it binge-worthy? It's learning presented in an engaging and entertaining talk show format that beats voice-over PowerPoint snooze fests. IT Pro TV offers an on-demand course library with more than 3,300 hours of content. Watch on your desktop, on the go, or in the comfort of your own living room. IT Pro TV is IT training you and your team actually want to watch, which means a better return on your learning investment. Get started with IT Pro TV for Teams with a special offer for Security Weekly listeners. Visit itpro.tv/Security Weekly to start a 7-day free trial and get 30% off a standard or premium IT Pro TV membership using the code SW30. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Welcome, everyone, to episode 0 of Application Security Weekly. 00 even, which is just awesome. I'm so excited to bring this new show on our network. I'm not even really your host. Like, I'm just Paul Asadoorian. I'm just here to try and look pretty, I guess. Your host for this episode and all subsequent episodes is none other than Keith Hoodlet. Keith, welcome to the show.
Thank you very much, Paul. Very glad to be here, and very glad to initialize this array of shows here on the Security Weekly Network. I think we're going to have a lot of fun.
Yes, absolutely. I just want to say, first off, I love the logo and the music that came together so nicely. Props, round of applause for our production team for making all that happen. Thank you very much. Keith, of course, what is your title? You work for BugCrowd today. What is your title at BugCrowd?
So I'm a trust and security engineer, and what that ultimately means is, being a small company, we do a lot in terms of a little bit of the prospective customer sales side in terms of being a technical trusted resource, some work on the security researcher side in terms of having a fuller understanding of what application security actually looks like today for a lot of our customers as they onboard, and giving them guidance and feedback on how to go ahead and remediate vulnerabilities that are found. But of course, then from there, we do other things like projects, development, making MVPs to hand off to the actual engineering team to then move forward with proper features and so forth. So we do a lot as a trust and security team, and I got to say, it's probably the best team that I've ever worked with.
That's awesome. Keith is a person that I would reach out to in the past and still to this day if I had questions about application development, and specifically questions about security as it relates to application development. And over the course of time talking with Keith, I'm like, we should really do a show on all this, because I would constantly bug Keith about, so when I do Docker and when I do this Node.js thing, like, how do I do it? How do I structure it? How do I secure it? And Keith always had great answers. And I'm like, this is awesome. You should be the host of a new show. And thankfully, Keith has accepted that position. And there's already some excitement on Twitter. I saw the Twitter kind of a chain go across that people are excited, which was interesting because people request a lot of things of us in terms of new shows. This topic actually wasn't number one, but it's number one in my heart for the new show that I wanted to create, because I feel that developers can benefit from having a more security-oriented message when it comes to development. I also believe that security practitioners today need different and more messaging and education and knowledge on secure development today, as I think there's been some huge shifts. Well, DevOps is like 10 years old, but I feel like just today it's starting to become more and more of a reality and more of the way that many places do business, and moving into a position where everyone will develop this way. Now, that offers some benefits and offers some challenges to security professionals, but I feel it's extremely important and different enough that we need an entire show where we'll do interviews and talk about news as it relates to application security. So I'm excited.
Yeah, I think it's going to be great, especially because for what we see, at least now, right, security engineers are suddenly being tasked with getting involved in the DevOps process. And a lot of people call it DevOpsSec or DevSecOps or what have you. But at the end of the day, really, security needs to be involved in that process in a transparent and in a fluid way, so that they're not disruptive to the process of the company producing features and producing ultimately what makes the business profitable. From there, it's just a matter of helping our listeners, both on the developer side as well as on the security side, being knowledgeable enough to move forward or ask the right questions so that they can actually be a part of that process in a way that is valuable to all sides of the business.
And I really think process is one of the key words there, is those processes that you may know and love or not love and remember in developing applications have changed dramatically. There's a lot more options today. That what's exciting for me is it makes your life better as a developer, and it allows for security to be built in and become part of the process in just a way, even in the way that you can push code faster than ever before and push out new releases faster than ever before. Even in just that one aspect, I'm like, this is fantastic. I mean, there are projects that I want to work on that really, I'm like, if I can just push out new code and new releases more quickly, it's worth whatever time investment I have to put into that project to make it happen. And so you've got some articles in there on the history of application security. I don't know if you want to start, Keith, by talking about and I think one of the fundamental things in kind of talking points is that transition from traditional waterfall development to DevOps. And so and then we also had Agile, which was kind of in between. Maybe a good starting point for me and our audience would be to describe waterfall development, Agile development, and DevOps in like a condensed, like just set the foundation, because those are terms we're going to use in the show probably quite a bit.
Yeah. So in terms of waterfall development is a simple process where you have long periods of development and planning that lead to maybe one or two releases in the course of a year. So ultimately, it goes through kind of a significant planning process out front in terms of the features that you want to develop and maybe the greenfield product that you want to produce, going into then all sorts of review as to how you're going to build it, what languages you're going to use, what sort of architectures it's going to be built on or supporting. And then it goes through a slow development cycle where it is finally released maybe at the end of 6 months to a year. And that is traditionally what a lot of companies would do. I mean, if you look at companies like Oracle or even Microsoft, where we're going to push Windows 95, and then we're going to push Windows XP a few years later, and then we're going to push, and so on and so on. It's a slow development process, and perhaps careful, which is nice to the extent that you can actually have a stage as part of that development that fits security very nicely and very cleanly, and may be able to push back the actual release cycle a little bit, but to the extent that it's not, it actually has a place in that waterfall lifestyle. Whereas moving into Agile, the whole idea of Agile is to move quickly, to be agile. I mean, it's right in the name. And so it's a matter of iteratively working through development in small pieces, but in ways that allow you to almost put the rails down on the track as the train is moving forward. Mm-hmm. So that way you have a constant style of release, you have a constant set of features that are planned and being worked on, Usually they use something called sprints. So you have like a 2-week cycle of development.
They're like mini, it sounds like Agile's like mini waterfalls.
Yep. Yeah, that's the best way to put it. And the thing that's different about Agile and DevOps in particular is that with Agile or with DevOps, you can push code to production multiple times a day. And so to that end, it's a little bit scary for the security folks because let's face it, if you've got developers pushing code to production multiple times a day, there's no time for security to actually say, hey, wait a minute, we need you to stop so that we can do this all appropriately. And so for a lot of organizations, and especially a lot of companies that have come about in the last 10 or 15 years, and especially in the security space, are trying to move left, or shift left is what everybody calls it, which is move to the very beginning of that software development lifecycle, help with the code scanning and review of the actual development or process of development as early as possible and as often as possible, so that you can go ahead and push things to production in a mostly secure fashion. The benefits to this is that, of course, you have things like continuous integration and continuous development tooling. So things like Jenkins or Travis CI. We'll go into the detail on those, I'm sure, in a future show. But again, it's just a matter of pushing code quickly so that you can get out and get that kind of first mover's advantage when any feature or product is released, so that ultimately your business can be profitable. So,
well, and that is one of the major differences between Agile and DevOps is you're not just pushing out new code, but you're pushing out the entire architecture over and over again. I think that's what really helped us enable the DevOps mindset, was having containers, microservices, and those such things, that you're not just rolling out new code, you can roll out essentially entirely new full suite of applications that include the operating system, the configuration, the application servers or any other services you require, and your code kind of all in one shot, broken out into multiple different microsegments, essentially, right?
Yeah, and to the extent that, that's something that's new within just the last few years, for that matter. So if you think about it, maybe 5 or 7 years ago, there, give or take, you would have like AWS instances as microservice instances, where you would just be able to like spin up a new image of maybe your website or what have you, if there was issues in the current iteration of that product or feature. And so the whole idea, or the whole concept of now being able to go a step further and actually have entire architecture in the form of, say, Docker containers that you can just simply spin up and replace in line. There's very little to no downtime experienced. And if there is downtime at all, it's maybe in the microseconds range, right? Like nobody notices that there was a shift over from this one feature set to a new feature set, unless there was major overhauls to the actual like UI UX. But yeah, it's a whole new world of both containerization, the whole idea of APIs and microservices now, where you have certain containers or certain features or functionality of the application that is intended to speak only to other sections of the application, but that they live all separately. They're not monolithic anymore. Things are broken down into very small pieces.
While we're on some of these foundational topics, Keith, the scariest question that I think I've ever gotten in recent times from a developer is, I was describing regression testing, and they're like, "What's regression testing?" And I was like, "Whoa, boy." Oh, boy. Not just, so how does that relate to producing code in applications with integrity that perform well, that have less bugs, right? Those are the like foundational elements of producing software. But also, how does regression testing play into security as well? And what is, so start with what is regression testing for our audience, because it's so important.
So when I was at Veracode, for example, I worked in the QA team for the binary static analysis tool. And so regression testing was more or less my task, is identifying regressions and then making sure that we remediated those regressions accordingly. And what that is it's basically you have an expected state of the application or the feature or the product, and functionality within that product regresses, meaning it actually breaks in some way or doesn't work as intended. And ultimately what you want to have is you want to have the code that you're introducing allow the application to work in the same intended ways as it was initially working, and then have that additional feature set added onto it. So to the extent that a developer might not understand what regression testing is today, isn't such a bad thing if you look at kind of modern developments or modern ideas, right? So there's test-driven development, which is you build a test to fail, and you build a test to fail purposefully. You then go write the code so that the test will pass, and you do that iteratively where you're always building a set of tests first and building out the code to make those tests pass as you work through the development of the product. And so to that end, you should, in theory, never have regression because you're always testing before the feature actually pushes live. The other side of that may, of course, lead to a developer not knowing about regression testing is the whole idea of continuous integration or continuous development, where if you have a build that is being produced as a result of code being pushed to like a GitHub repository or what have you, and it's making sure that all of the tests, or in this case, regression tests, for lack of a better term, pass, in some cases that's security scanning as well, then that build can get pushed to production accordingly. And if a developer is never actually, basically they followed all of the rules of development with the organization that they were working with, that they never had a build break, they might not understand the whole concept of regression testing because they're doing it live effectively.
Yeah. Well, and I think in any model, it's important that when it's not just with features, but with bug fixes as well, that those get pushed into a system that I may have changed one part of the application. It could have been something as simple as a bug fix, and it could have been a very simple bug fix, but it's important that that application goes into a QA environment and all of the other features of that application are tested to make sure they still work. And that's kind of how I think of regression testing is as more complexity is introduced in your application, more dependencies could be there, and you may not know what could break without some kind of automated testing inside of your application. So I may make a bug fix in one area, not realizing that there was some code that relied on that is now broken. And my test of my bug fix and it worked, but I didn't test that other piece of functionality to make sure that it still worked. And that, is regret. And normally we would do, I feel like in waterfall development, regression testing was something that was done every once in a while. Like we'd fix a bunch of bugs, put in a lot of new features, and just kind of keep going, and then go, oh, by the way, we got to go back and do some regression testing, and then have a whole bunch of new bugs. What Keith, you're describing is we keep moving forward, right? We're making changes. Those are automatically happening on the fly. I like your analogy of as the tracks are being laid down, we're continuing to build.
And I think that a lot of people today, especially developers, would notice this to be something like unit tests and integration tests, right? Regression testing, it traditionally was you build, like you said, a whole set of features or a whole bunch of bug fixes. You put it into the code to make sure everything still works. Usually it's a very manual process where the actual QA team will go about making sure that the tests pass. That's effectively what I did at Veracode. But now what you actually see is you have a unit test which makes sure that the piece of code that I have written works as intended. And then you have an integration test or a suite of integration tests that make sure the piece of code I've written doesn't break anything else in the code base. And those are usually run as part of a continuous integration model, whereby you push the code up to a repository. It then tries to build that code out as part of the entire product or feature set. And then from there, it will go ahead and say, okay, yeah, there's nothing that's broken according to all of the unit tests for all of the other pieces of code, and of course, all of the integration tests accordingly. The interesting thing, and I talk about this a little bit in one of my talks that I give on attack-driven development, is the whole concept of, well, if I have a lock on a door and I test that the lock functions appropriately, I can close and open the lock, and the door still functions where it can open and close, the security side of this is, does the door open when the lock is closed? And a lot of the time, development doesn't think that way, which is, I think, part of the benefits of the show is making sure that when you're writing unit tests and integration tests, that if you have features that are intended to be security features in some fashion, you're testing that those are also working appropriately in terms of the failure state works appropriately as well as the open state.
Keith, you've got some great articles in here on, the first one is the history of application security, which is, it's interesting, is the second time in the past couple of weeks we've mentioned Rainforest Puppy, which I had forgotten about. Some of the really awesome things that as a security researcher he put forth in how that plays into application development, which is kind of interesting. I'd like to get him on for an interview. I don't know if anyone knows what Jeff is up to. That'd be cool.
That would be awesome. I mean, it's weird to think that SQL injection is 20 years old, right? Or at least according to theories of injection, it dates back to 1998. And so it's an interesting thing to see, especially in that time frame, right? So talking about the whole rise of application security, the only reason that any of this exists is as a result of the ecosystems that have come about from things like the .com era, right? So 2001, the OWASP Foundation or the OWASP project was put together. So the reason that that comes together is because of the fact that back then was the huge .com boom and bust, where we saw things like Yahoo, Google, Amazon, and a lot of other major players in the space of just technology industries today exist that at the time were just forming. They were just coming into existence. And as a result of that, now, 18 years later, 17 years later, we actually see this whole idea of serverless architecture or cloud or any number of different things that have led to the need for application security, because ultimately it's the applications that are the business. Amazon.com is an application that is making money for the company Amazon, as opposed to your traditional like mom and pop shop sort of things.
What else? You got a couple articles in here. I don't know if you want to briefly describe them before we go on to the next segment, and encourage our listeners and viewers to visit wiki.securityweekly.com, go to Application Security Weekly, and you can find all of the links and notes that we talk about during these shows.
Yeah, so one of the things that I like to talk about here, especially is I put a link in there to Gary McGraw's A Brief History of Security, or excuse me, of Software Security and Software Security as a thing. And he is one of the founders of BSIM. So in this case, that's the Build Security in Maturity model. So as in like put security in the process of development. And inside of that, he talks a lot about how software is effectively eating the world. And also, of course, that at the time anyway, in the whole SDLC model, penetration testing happened right at the end. And let's face it, today with a company that is its entire business model is related to a website, for example, think of maybe like Salesforce. They're not going to pen test right before releasing a feature. And if they are, even if they find things that are bad but not earth-shattering, they're still going to release that feature and go back and fix it later, which in today's world of DevOps, if you're pushing code to production 3 or 4 times a day, that just doesn't work. Ultimately, if you put a pen test at the end, you're not going to stop the feature from being released, period. So I think that that's his whole slide deck definitely talks to a point in security that we were maybe 10 years ago, which is we should be testing throughout the process of development and thinking about this at an earlier stage. But because DevOps and Agile exists as it does today, getting there early means just being embedded or being an ambassador into that development cycle itself. So literally sitting alongside those developers, working with them to make sure that they are thinking about security as part of that process of development, and then making sure that you're just kind of injecting those little pieces of security into the thought process. So making sure that when the lock is closed, that the door does not open appropriately, and making sure that the test is built to achieve that sort of state. So other articles in there, though, I did put a couple in there from Checkmarks, which talks about kind of the rise of application security in more modern eras, especially the part 2, which talks about things like bug bounties, which, again, working for BugCrowd is something that's come up in the last 5 years, which has been an interesting change to the traditional pen testing model. And I think that that has been given rise to the fact that DevOps is ultimately moving very fast, so you can't afford to have a pen test every week. So instead, people are moving to this pay-for-results model of bug bounty programs. But in addition to that, it also talks about things like the Trustworthy Computing Group, or Trustworthy Computing team at Microsoft that was formed back in 2002. And I think that in a lot of ways, that whole idea of having dedicated teams to security, especially in the application side of things, comes about from leadership like what Microsoft has done. But at the end of the day, I like to think about broader topics that led to application security even coming into being. And in the same way that I think that the reduced cost of storage or disk space over time ultimately led to the security incident and event management market existing, because if disk space was still expensive, you wouldn't be able to store all those logs, let alone review them. So in the same way that cloud environments have come into being, in this case, DevOps, or being able to push production quickly with microservices and containerization like Docker, has allowed developers to move faster. And ultimately, because of the dot-com boom, bust, and eventually now, I think we're in another boom again where we have a lot of multi-billion-dollar companies that are almost solely software-based. As a result of all of those things coming together, we see application security becoming more and more important to organizations that are getting off the ground. And instead of offering a product in terms of a device, they're offering a service of some kind, whether it's a platform or software or infrastructure. We see all of those, star AAS monikers that have been thrown about lately. And that's ultimately, I think application security exists because of the fact that companies are moving towards software as a solution for sales. And we even, well, ironically, and we'll talk about this in the news segment, we still see software security being a problem at the hardware level, as with the Intel and supposedly AMD and ARM architectures being vulnerable to a couple of different things that have come out in the news this week.
Awesome. All right. Are we ready to take a break and come back and talk about news and learning and tools?
Sounds good.
All right. Let's do it. Welcome back, everyone, to Application Security Weekly. I am here with Keith Hoodlet from who works for BugCrowd, and is my go-to source for application and application security topics. And so we decided to do a show, and I'm excited to talk about a bunch of news articles as well as some learning topics and tools. Let's start there and talk about what is hacksplaining.
Sure. So Hacksplaining is a neat website. It's free. You can just sign up on it after you go through kind of the precursor free open. I guess articles is not the right thing, but modules is maybe the right word here. Basically, what they do is they allow you to go ahead and just kind of walk through what are simple examples of different vulnerability classes, whether that's SQL injection, cross-site scripting, clickjacking, and a lot of others. And from there, those lessons go through not only what it is and how it actually comes about or how it exists in an application, but then they go into like a write-up of how that might exist in the different sets of code that it could be presented in. So once you've gone through the example, it will then have you go ahead and look at, okay, if I have Python, how would a SQL injection take place and how could I mitigate this? If I'm writing in Ruby, if I'm writing in Java. And so it actually goes ahead and gives you examples of bad code versus good code. And then at the end, it has like a brief 3 or 4 question quiz so that you can complete the module. What's really nice about it is it's free. So basically, you can go through the initial 4 lessons on SQL injection, cross-site scripting, command execution, or clickjacking. If you like it, go ahead and just sign up, and you can continue with the rest of the lessons. It's very informative, and especially from the development side, it's really kind of nice.
Sweet. I'll have to check it out. Burp Vulner Scanner. That's what it says.
So this, this is a little bit dated.
It's not a typo. It's not a typo. This is
nope.
This is an actual GitHub project.
Yeah. So this is it's a little bit old, about 6 months old now. But I like to point it out because they recently released, and I put this in the show notes for the news section, an Nmat plugin that does exactly this, which is It's a scanner that identifies vulnerabilities based on responses of the server. And what's nice about for an application security standpoint, if you're running different versions of, say, IIS is the big one that I always see, and that's part of the response back from the server for the web application itself, it will tell you the different CVEs and their CVSS scores for those different vulnerabilities that exist. So whenever I'm doing application security research in my free time, what I'll do is I'll go ahead and crawl the website accordingly, and the Burp Vulner Scanner will start to collect and aggregate based on information that is responded back to from the server, potential vulnerabilities that might exist in that application that I should pursue and test further. So a good example is, I think it's IIS 7.1, and I could be mistaken. I'd have to go back and look at this appropriately, but it has an FTP upload vulnerability that allows you to, I believe, upload beyond a specific size and potentially denial of service the application based on a very large upload, for example. So the Burp Vulner Scanner that has now got an Nmap plugin associated with it for the Nmap scripting engine, I believe, is something that I use as part of Burp, but also you can now use as part of Nmap as well for identifying those server-side vulnerabilities.
Sweet. And, of course, the SANS poster.
Yes. So this DevOps toolchain poster, and I imagine that this is going to give guidance to a lot of what we're going to talk about here on Application Security Weekly, goes through the entire development chain for DevOps. So it talks about a lot of the different tools that exist, and then, of course, where they fit in the lifecycle of development. So you've got your pre-commit, and then, of course, there's a whole threat modeling or security and privacy stories, pre-commit security hooks, and so forth. So different tooling that's available. Commit, acceptance, production, and operations. And if you're in any one of those different stages as an engineer or as a developer, you probably are using some of these tools already. Like I'm looking right now at the acceptance section, and you've got immutable infrastructure like Docker. So having different tooling that's available to you from a security scanning as well as from a development side is really nice to just have a consolidated list. I was talking about this with my manager, Jason Haddix at BugCrowd, and he asked, where can I get a poster size of this that I can hang on my wall? And I said, I don't know, but I also would like one, and I think that's something that would be great for your developers as well, Paul, there in studio. So,
yeah, absolutely. We're going to get some of those posters. I know some people at SANS, so.
Perfect. And yeah, be sure to get one of these hanging up so I can put it in the background here for maybe the next show or what have you. So
yeah, that'd be awesome. All right. What do we got in the news?
I was going to say is I want to jump right into one of the things that I found somewhat telling about the industry that exists today, which is that companies are actually starting to design their own courses to train their hires on new technologies that exist. Basically, what is happening is companies like Microsoft, Amazon, Google, and what have you have found that even some of the best schools that are producing computer science or software engineering graduates are not preparing the new developers adequately for what they're ultimately using today, which is, again, that DevOps cycle and a lot of those tools that are in the SANS Secure DevOps toolchain. And so what is happening is some schools are starting to do more of like an edX model supplemented with in-class lessons and assistance from teachers, where effectively we're moving so fast in terms of new developments, new infrastructure as code, new features that exist in terms of the whole development lifecycle. And because of that, schools just can't keep up. And now we're seeing this really great article on how some schools are starting to integrate with large companies like Microsoft to take the actual lessons that Microsoft has produced and put them right into their curriculum, which I think is awesome. But at the same time, it's somewhat telling that maybe we have education as a waterfall model, and we're starting to see the rise of DevOps in education, which is companies building the courses that they actually need their engineers to know.
Yeah, I like that a lot, actually, customizing it.
And yeah, I mean, I think it's great, and there's a lot of available education out there. IT Pro TV, for example, is a lot of really great courses, and I'm actually looking forward to checking out their Vue.js course, which is a new JavaScript framework that does a lot of really interesting things, and I've heard a lot about. The next one that's actually in the news, though, and it's been somewhat eclipsed by the latest Intel and CPU architecture vulnerabilities, is a Mac OS 0 day that was dropped on December 31st, right around 5 p.m. Eastern, if I'm not mistaken. It goes by the name IO Hideous, which is basically it's part of the IO HID family, or Input-Output Human Interface Device family of libraries that exist in Mac OS. And it's ultimately the write-up itself. And if you get a chance to go look at the show notes, this write-up is very deep, very technical, but it's really beautiful because it talks about a memory corruption flaw that exists where the library that itself that is ultimately vulnerable and looks to have been vulnerable since about 2002 basically points to a specific segment of memory that may have a changing size. And so as a result of that vulnerability being introduced, an unprivileged user, so someone that's just a normal user on a local device, could ultimately get kernel memory execution, so both read and write, and at that point they can get privilege escalation and they own the system. So the reason that this was dropped publicly as a public disclosure, according to the actual researcher that discovered this, was it wasn't remotely executable, and Apple doesn't have a bug bounty program on Mac OS. So because of that, they said, you know what, I'm just going to go ahead and release this. And they actually did a very, very nice write-up of how this all happened and proof of concept and the whole works. So definitely hats off on this one. I think that in terms of the Pony Awards for 2018, best research could very well come down to this, or of course the Intel CPU vulnerabilities that have recently been disclosed as well.
Keith, why doesn't Apple have a public bug bounty? Do they have a private bug bounty on Mac OS? It's just not public. Is that the deal?
So my understanding is they actually don't have a bug bounty on Mac OS at all. So again, this is something that was talked about a lot with the root vulnerability or the no password vulnerability that existed a couple of weeks ago, or maybe that was about a month ago now. Mac, or Apple, I should say, has an iOS bug bounty program, and I believe that's invite only, if I'm not mistaken. So it's not necessarily private in the sense that it's not like, publicly disclosed. It's public. I think it was announced at Black Hat a couple of years ago, but it is invitation only. The payouts are pretty high from industry standard for bug bounty programs, but again, when you look at things like the black market for iOS vulnerabilities, kind of pale in comparison. So I'm not sure why they don't have a Mac OS bug bounty program or even a public disclosure program of some kind. I think that's something that they've been encouraged to do time and again, especially in light of recent events. So who knows? I mean, maybe this will come about as a result of the 0-day being launched. Maybe not, because it's been overshadowed in the news and not a lot of people have been talking about it.
So now what's going on with the CPU design flaw? There's a lot of people talking about this, Keith.
Yeah, and in fact, so last night on Pulse Security Weekly, I talked about this a little bit, and I actually got the vulnerabilities mixed up a little bit. So let me make sure I make a correction on that, which is the meltdown vulnerability, which is a vulnerability that exists in CPUs such as Intel, ARM, and potentially AMD as well. It is all about basically what's the right word for this? Speculative execution, which is an optimization feature that exists in CPU architecture. More or less what happens here is the actual code that's being run at the CPU, it says, okay, I believe that, and I should actually make a correction right here. So Meltdown is specific to Intel. Spectre is potentially Intel, ARM, and AMD. So Meltdown is Intel privilege escalation and speculative execution allows basically an unprivileged user to read kernel memory from user space, which is potentially a vulnerability that could affect cloud infrastructure, shared hosting infrastructure. And what this means is, ultimately, if I am able to go ahead and get some sort of Intel privilege escalation, the speculative execution is a CPU optimization that allows for the CPU to pre-compute the predictive path of code execution that it anticipates taking place. It then will cache that code execution results. And from there, if that branch actually does execute accordingly, it's already done. It's already done the work for you. But if it doesn't, it has to kind of roll all of that back. And ultimately, this vulnerability leads to the ability for an individual to read kernel memory from user space as a result of that bad execution path caching the memory in a way that is not safe. And so from there, basically, if you're in a shared hosting environment, I have code execution on the AWS or the Azure instance that I'm using because I'm a privileged user to that end. So I'm allowed to go ahead and have code execution there. If I can read kernel memory, then I have the potential of being able to then execute code or even read code, I should say, in other memory spaces along that shared host environment. So that's where the cloud architecture problem comes into play. Spectre, on the other hand, is a branch prediction and speculative execution vulnerability. So effectively, if you have branches of code that may execute in different ways, and then speculative execution runs down that predictive branch accordingly, it's the same sort of problem, but it's slightly different in the sense that it's not tied to a privilege escalation in Intel. It's, in this case, predictive analysis of where the execution is going to take place, and then using that speculative execution vulnerability to then leverage code execution, which allows you to go ahead and read contents from memory of other users running programs. So both of them are tied to really what should be considered flaws in shared hosting environments. Of course, it could be something that someone executes locally on your system itself if they're an unprivileged user. But I think the real scare here is we run this thing called the cloud these days. A lot of companies are leveraging it. And to the extent that both of these vulnerabilities have potential issues that need to be addressed is no small thing. Thankfully, and I think that the thing that should be said here is large companies like Amazon, Google, Microsoft with Azure have probably a faster response time than I think any other smaller company is going to have when it comes to making sure that patches are pushed on this. And so to that end, people should definitely go ahead and perform any sort of local mitigations, because this is actually something that is a potential flaw from like the browser side. So for an individual user, JavaScript can execute these vulnerabilities locally to your system. So there is guidance out from Mozilla, there's guidance out from Google on how to go ahead and mitigate this with impending patches anticipated to take place for those specific browsers, as well as, of course, patches at the operating system level from, in this case, Apple, from Microsoft. I imagine that the Chromebooks have probably had patches pushed, given that, of course, Google's Project Zero is the ones who ultimately found this and disclosed this to Intel ultimately, and then I believe onto ARM and AMD as well.
Awesome. That's a great description.
Yeah, we have a lot of stuff on this too. So if you want more, go look at the show notes. Postgres is talking about how they leverage speculative execution and anticipate some slowdowns in the way that the database the integrations with the database or interactions with the database take place. So there's a lot out there on this, and this is very new. So stay tuned on probably more from this.
You had a link in there also from the vulners.com GitHub repository that ties Nmap. Basically, and again, I've been reviewing the code while trying to listen to Keith talk at the same time, and I suck at multitasking. It looks like it's taking the version string from an Nmap scan and comparing that to some kind of feeder database of all published CVEs to give you back a list. I just want to caution people that while that's a nice quick check, that leads to, in my background working for Tenable for 7 years, a ton of false positives and false negatives just because of the way that software produces that version string. As an example, most Linux distributions will backport patches and not update the version number. So that leads to a number of different false positives, which is why many vulnerability scanners have to actually test for the vulnerability rather than just rely on the version string. Although it can be a nice, quick little check. I just wanted to point that out.
Yeah, this is definitely a good place to start, I think. It's, again, not a free solution that's going to replace anything that you might otherwise use in the enterprise today. But to the extent that it is a good place to start looking for potential problems, and in correlation with other information that you may have, you can then start to discern what's a true positive versus false positive or false negative. And to your point, Paul, there's a lot of different tool sets out there today that allow you to even do patching in memory for Linux, whereby you're not even necessarily backporting the patch, but the patch has been applied in memory for that library, and there's no way that a scanner is going to even detect that that exists. So yeah, potential for false positives there. Definitely got to follow that up with some actual hands-on work to make sure that you're not just pushing out a report that says, yeah, they were vulnerable or not vulnerable to all these different things.
Yeah, I think it's a good individual kind of script to run against a single host or application to, as a check to say, these are some potential vulnerabilities you might want to look out for.
For sure, for sure. Did you want to move on to the Wi-Fi miner or the Starbucks Wi-Fi mining?
Yeah, let's talk about that. I think that's Well, it's interesting because we were talking to Marcello last night on Paul Security Weekly about injecting JavaScript in via Wi-Fi, which I just think is really cool.
Which is exactly what this problem is in this case. So ultimately what ended up happening is someone notified Starbucks that their Wi-Fi at their Buenos Aires, one of their Buenos Aires locations, was causing a 10-second delay when they connected to Wi-Fi, and was actually injecting JavaScript into some of the requests to do Monero mining for that Wi-Fi connection, as they were connecting to the, or for that connection as they were coming onto the Wi-Fi. And so ultimately what ended up happening was Starbucks looked into this. It looks like it was actually the ISP, or supposedly it was the ISP, that was actually injecting this JavaScript into the requests accordingly, which is pretty concerning considering an ISP probably is doing this for a lot more than just that, Wi-Fi at Starbucks. But it's a situation where, again, we've come to a point in time where Bitcoin or even cryptocurrencies are a huge deal, and there really are moving markets. I think Monero, according to this article, was valued at something like $300 and has risen over 1,500% in the past year. So the fact that we're probably going to see more of this, not less, is a reality that from this article we're starting to see. And in fact, someone actually took this whole concept and built out a proof of concept, which is another link in the news that we've continued to include as well, which shows that this is actually not only possible maybe from the ISP, but also possible from like a Wi-Fi location itself on a real Wi-Fi network. So we've included that in the show notes as well.
Now, how did they get the code to inject over the open Wi-Fi? Is that a physical location? Like, did someone physically go to the Starbucks and drop a device off, or like how are they injecting the JavaScript?
So I'm wondering if this is some sort of like, I don't know if it's necessarily header related, but as the ISP, they control the upstream requests that are being pushed around. And so if the connection to that Wi-Fi hotspot for connecting to it itself, so you have an open Wi-Fi, you connect to it, you go to log in, it's probably going to have some sort of like, I agree to the terms and condition button.
Oh, and that's where the JavaScript,
Yeah. So that might be ultimately where if that page is not necessarily HTTPS enabled, they could be injecting that into the upstream requests, especially at the ISP level. So they can say, okay, cool, you're making this request up to this page, or the ISP that's serving it, so we're going to inject this directly into your request as it goes upstream in a somewhat seamless manner, which is, I think, where the problem lies. It's similar to, I think, what a lot of people have been concerned about in the last few years to zombie cookies. So companies like Verizon, I think, were called out on this, where they were injecting cookies into requests so that they could track all of your behavior online in a way that couldn't be mitigated from the user end. So it's definitely something that, with the whole rise of cryptocurrency, again, being another application security problem that we're facing, we're probably going to see more of this. So I imagine we're going to have a lot more articles on this over the course of this year.
Awesome. What else we got?
So I know that we're probably looking at wrapping up here soon. There were two articles that I definitely wanted to cover for this episode segment. One of them is called the 100x Engineer. And it's not necessarily about tooling or about individual knowledge in terms of like knowing a specific language, framework, or library. But what it does talk about is it talks about how we go from being engineers, not only from like the software development side, but also I think this is more applicable today to security engineers, which is how to make yourself have 100 times the impact that you otherwise might have at your organization. And toward the very end of the article, they talk about a few very specific things that, beyond just technical know-how, I think are valuable. The first of which is communication. So knowing how to effectively communicate with your development teams, which is something that we hope to enable our listeners on, as well as being able to effectively communicate the importance of findings or of practices internally, is something that allows you to have an impact beyond just yourself. You can go ahead and have influence over the ways in which things are designed, for example. There's also creativity, so that's something that I think is necessary for just about every security individual, regardless of being in application security or otherwise. So being able to think beyond the problem itself, but come up with creative and in this case, hopefully also secure solutions to a problem in a way that is fluid and makes sense. Of course, the last three here, empathy, I think is probably the most important. Of course, we often look at the developers or look at the users and say, why did you do that? But at the same time, I think that to be effective, having that state of empathy with the individuals that you're interacting with, and understanding the problems and the deadlines and the stress that they're under allows you to be more effective with your communication and with the ways in which you bring about or address problems that might be coming into play. The last two, negotiation. So in this case, being able to negotiate a minimal viable security, as Michael Santarcangelo would like to say, to be able to bring them to a state of good enough without letting good enough be the enemy of perfect, or in this case. And then lastly, of course, technical. You have to really understand or know what you're talking about to be respected and treated as having a seat at the table. If you are just throwing around buzzwords and you don't know what any of them actually mean, you're probably going to lose that credibility pretty quickly. And then from there, you're going to lose influence and so on and so forth.
This book I'm reading is so good that I almost don't want to tell everyone about it because I want the upper hand by being the one who's read the book. But when we talk about empathy and negotiation, the book I'm currently reading now that we've talked about on Startup Security Weekly, which is now Business Security Weekly, where we talk about these topics in depth, Keith, is called Never Split the Difference from Chris Voss. Working on getting Chris hopefully to appear on our Business Security Weekly program. Like the best has helped me so much in so many different aspects, specifically with some of the situations you've talked about. Chris Voss was the FBI's lead international hostage negotiator and has gone on to teach classes in business that apply those techniques he learned in negotiating for hostages into some lessons for business, and also talks about the exact same things you're talking about, Keith, in terms of empathy and negotiating and how that plays in a business setting, whether you're negotiating for a team to implement a security project or whether you're negotiating for a position at a particular company or an increase in salary. And there's tons of different stories that Chris shares from his students that say, I learned from Chris and I applied this to my career in this way. So it's really good. Never Split the Difference by Chris Voss.
Awesome. Definitely going to add that to my Kindle reading list at this point. So I've added a few books recently. I intend to do a little bit more reading this year, which I already do a lot of anyway. So I'm definitely going to be adding that. I know that we're getting close to wrapping up here. Did you want me to cover this last article a little bit as well?
Yeah, sure. One more. Let's do it.
Sure. So interestingly, UpGuard had an article that came out basically saying that millions of American households were exposed online. So Chris Vickery at UpGuard wrote a really good, or found basically an open S3 bucket that had detailed information on, in this case, I think it was 123 million American households. And so to that end, the details of the information that was actually disclosed on this database was all sorts of nitty-gritty information that would allow for effectively someone to have their identity stolen. Maybe not things like social security numbers or birthdays, but enough information about maybe where they've lived, maybe things that they've recently purchased, all sorts of like little minute details that could be a problem. The most interesting part, I think, about all of this, though, was the reason that this vulnerability came about was the AWS S3 bucket was configured with permission settings to allow any AWS authenticated user to download its stored database. And ultimately what ended up happening was the individuals that set up this database thought the AWS authenticated user was an AWS authenticated user within their virtual private cloud. And this is kind of the heart of application security, is thinking about the ways in which even something as simple as UI UX can affect the security of infrastructure that you're rolling out. I had a great conversation with Gwen Betts at Command, which is now owned by Rapid7, at this past DEF CON 617 about UI UX and the importance and value of having that done right in an organization. And this is a very clear example of thinking about the security implications of something as simple as a setting and the UI UX of establishing a database. So I'm sure we're going to talk about a lot more of those sorts of things this year. But again, I thought that this was a great article. Again, Chris Vickery as well is a hound dog for open S3 buckets. And he's bound to find more this year, I'm sure.
And Gwen is awesome too. I also know Gwen and think she's awesome. So that's cool.
Yes, I agree.
We'll have to get Gwen on the show.
For sure. I agree with that 110%.
There you go. Gwen, if you're listening, we want you on the show. How about that? Keith, thank you so much for putting together this edition, this first episode 00 of Application Security Weekly. Thank you, everyone, for listening and watching. We'll see you next time.